Once again, welcome to my class here, and here I am going to discuss a problem from the exercise 6.2 of your Ncert book of similarity of triangle. Here is an Ncert problem, question number 9. Okay, and it is an use of the concept of basic proportional theorem and converse basic proportional theorem. Okay, BPT and converse BPT concept we are using here. Okay, and in this statement it is given that a trapezium is given, and the trapezium diagonals of trapezium intersect at the point O. Here ABCD is a trapezium given. It is given ABCD is a trapezium. ABCD is a trapezium, and the diagonal AC and BD intersect at the point O, and we have to prove that AO upon BO is equal to CU upon DO. That you have to prove. Okay, let us do a construction for that, because this is a problem that we have to prove. The mathematical statement you have to prove. Okay, using the concept of the basic proportional theorem and converse BPT theorem. Okay, so that a construction is required for that. What is the construction you say? Through the point O, draw OM parallel to AB. Okay, so OM parallel to AB is done, which intersect AD at the point M. Yes or no? This is the construction, we have to prove it. Okay, understand? So this is the construction for the required statement, right? Okay, ON parallel to, you see, OM parallel to AB is done. OM parallel to AB is done. Okay, now proof. Look at here in the triangle DAB. In the triangle DAB, look at here. OM parallel to AB. OM parallel to AB. Once again you see. Since OM parallel to OB. OM parallel to AB. Yes or no? And AB also parallel to what? CD. So that implies OM also parallel to CD. Can you say also? OM also parallel to CD. Right? Okay, now in the triangle, you see the triangle, in the triangle DAV, look at here, in triangle DAV, OM parallel to AB, in triangle DAV, okay, look at, let us remove this one, this point, we can clearly do. Now, see now, in triangle, okay, in triangle DAV, you see OM parallel to AB, so we can use the concept of the BPT, theorem of BPT, that what you can use now, AM upon DM must be equal to, in the triangle DAV, so BO is equal to DO. Yes or no? By BPT concept, look at here. Okay, in the triangle DAB, look at here, and OM parallel to AB, MO parallel to AB, so AM by DM is equal to BO upon DO. Okay, if a line run parallel to one side of triangle, it intersect other two sides in the same ratio. This is the BPT theorem. Okay, similarly, you see now, since OM parallel to AB, that's why OM also parallel to CD. Okay, similarly, in triangle ACD, Look at here, OM also parallel to CD. Why? Since AB parallel to CD. Since ABCD is trapezium and OM parallel to AB, that's why OM is also parallel to CD. So in the triangle ADC, look at here, OM parallel to what? AB. OM parallel to CD in the triangle ODC triangle. Look at here triangle. You can draw a triangle for that. You will clear over that. Let us draw a triangle. Which triangle? A, D and C. Okay. Understand? And this is the point O and this is the point M. You see OM parallel to CD. OM parallel to CD. Yes or no? OM parallel to CD. That's why AM upon DM. Similarly, according to BPT theorem, AM upon DM is equal to AO upon CO. This is also as per the BPT theorem. Right? Okay. Now equation 1 and equation 2. Equation 1 and equation 2. And you see AM by DM is equal to BO by DO. And equation 2 AM by DM is equal to AO by CO. Now you can compare the equation 1 and 2. And after comparing you can write that implies BO upon DO is equal to AO upon CO. Okay? Understand? BO upon DO is equal to AO upon CO. Okay? Now just you can transpose. Okay? Yes or no? Now you prove that AO upon BO is equal to CO upon DO. Understand? Okay? Now you can transpose AO taken to the left hand side. So BO upon AO is equal to DO taken to the right hand side. CO, DO by CO. So BO by AO is equal to DO by CO. Yes or no? Okay? Just to reciprocal it and you will get that. So BO upon AO must be equal to AO upon if BO upon AO is equal to AO upon BO and DO upon CO is equal to CO upon DO. So after reciprocal we can get, and let's see, and here we are getting the AO upon BO is equal to CO upon DO. Okay, this is what you have to prove it, and it is another simple problem for you. Okay, and here you can easily application and the use of the BPT theorem. Okay, using that we are going to prove. Okay, thank you all of you. Thank you. So let's see and watch it. Okay, and this exercise already practice it properly once again. Watch this exercise again and again. Okay, and also practice also again and again, and also practice the similar type of problem. Okay, with this, thank you. See you for the next class. And here I am going to discuss the problem from Ncert book, exercise 6.2, question number 10. Here I am going to explain for you. Okay, and this is another interesting question based on the concept of the basic proportionality theorem and converse basic proportionality theorem. Okay, in this question it is given that ABCD is a quadrilateral and the diagonals of the quadrilateral ABCD intersect each other at the point O, and AO by BO is equal to CO by DO, so that ABCD is a trapezium. So students, it is given that it is a quadrilateral, we have to prove it is a trapezium, so we have to do the diagram according to given part, according to axing part. What is question is axing, always you know. Okay, and what is question is axing, we have to the diagram accordingly. Here it is a ABCD is a quadrilateral and to prove it is a trapezium. So our diagram should be in such a manner that it should look like a trapezium. Okay, and you see now here you see ABCD is a quadrilateral and the diagram looks like a trapezium because you have to prove it. That's why the diagram should be accordingly. And ABCD is a quadrilateral. ABCD is a quadrilateral given. ABCD is a quadrilateral, not trapezium. We have to prove it. ABCD is a quadrilateral. not trapezium, is a quadrilateral. Understand? And another thing you see, the diagonal AC and BD intersect at the point O. Okay? And diagonal AC and BD diagonal intersect at the point O. This is another given. Okay? And again given that AO upon BO is equal to CU upon DO. Okay? That you. It is also another fact given that AO upon CO is equal to BO upon BO. AO upon BO is equal to CU upon DO given. Okay? Understand? So this much given, and you have to prove that ABCD is a trapezium. It means we have to prove that one pair of opposite side AB must be parallel to CD. Then it can be a trapezium. Okay. Now for construction, one more construction we have to do, because we have to prove it according to the basic proportionality theorem and converse basic proportionality theorem. That's why you have to draw a line through the point O. Draw a line through the point O, a line. Okay. And MN is drawn through the point O in such a manner that MN parallel to AB. Is it clear? Now the line MN is drawn through the point O such that AB parallel to MN. Okay, this is the construction for the given question. Now let us prove it. Okay, understand? Is it clear? Okay. Okay, let's see. This is the given, and this is the what to prove, and you have to prove it is a trapezium, and also the construction you already know what should be the construction. Let's see how to prove this one. Okay, students, now let us see. Now see in the triangle ABD. In triangle ABD, what are you finding? MO parallel to AB. Why? Because as per the construction MN parallel to AB, it has been constructed. So since MN parallel to AB, MO parallel to AB, because MO is the part of MN. Since MN parallel to AB, so MO also parallel to AB. So you can use the basic proportionality theorem. Yes or no? So what do you use? AM upon DM is equal to AO upon CO by BPT. Okay? By basic proportionality theorem. Understand? Is it clear? AO by? Yes or no? Yes or no? Again you see in the triangle. Yes. In the triangle ABD, I think you see AM upon DM is equal to no. BO is equal to DO. There is a mistake. Sorry, extremely sorry for that. Because you see DAB. Look at here. Look at the diagram I am doing. Here DAB is a triangle. In this triangle, what? MO parallel to what? AB. So AM upon DM is equal to BO upon DO. Okay. DO upon DO. This is one of the mistaken. Okay. Is it clear? Okay, because OM parallel to AB. OM parallel to AB. So AM by DM is equal to BO by DO. This is one of the mistaken, and it is correct. Understand or not? Okay. Is it clear? Similarly, you see in the triangle, another triangle ABC. In the triangle ABC, look at in the triangle CAB triangle. In triangle CAB, look at here. The triangle CAB. In the triangle CAB, can you say ON parallel to AB? Yes or no? OM parallel to AB. So, can you say AO upon CO is equal to BN upon CN? Yes or okay? Similarly, in the triangle CAB, look at here. AO upon CO is equal to BN upon CN. BN upon CN. Same concept of the BPT, basic proportional theorem. Understand? Since ON parallel to AB, so OA upon OC is equal to BN upon CN. Right? Understand? Okay. Again given that, what is given, you see? AO upon BO is equal to CO upon DO. Yes or no? Okay. So that implies AO upon CO will transpose CO. Okay, will be transferred to the left hand side. So numerator will be denominator. BO goes right side. It will be BO upon DO. Can you write or not? Can I write or not? Yes. Okay. Understand? So now let's see. Okay. Now see AO upon CO is equal to BO upon DO. And again AO upon CO is equal to what? You see now, again AO upon CO is equal to BN by CN. BN upon CN. And AO upon CO is equal to BO upon DO. Okay. Look at it once again. AO by CO is equal to BA upon DO. And BO by DO is equal to how much? A upon AM upon DN from the equation 1. Yes or no? Yes or no? You can write AM upon DM. Clear? AM upon DM. Right? Okay? Understand? Okay. Here you see. Look at here. From this you see, closely you observe here. You see now AM upon DM. AM upon DM is equal to AO upon CO. AO upon CO. You can get another point also from this, from the previous statement. You can write AM upon DM is equal to AO upon CO. Right? Now you see the triangle ACD, OM parallel. Now look at here. In the triangle ACD, what are you observing? You see AM upon DM is equal to AO upon CO. It means according to converse basic proportionality theorem. Can you prove OM parallel to CD? Can you prove? Yes or no? Yes, can you prove? Okay, let's see. Now see, look at here. In triangle ACD, look at the triangle ACD. In triangle ACD, AM upon DM is equal to AO upon CO. Okay, from the equation 3. Okay, so since, okay, look at here. This is A, this is D, and this is C, and this is what? M, this is O. And you see AM upon DN is equal to AO upon CO. So this is in accordance with the converse basic proportional theorem. We can write MO parallel to CD. by converse BPT, by converse BPT, by converse BPT. Okay, and since MO parallel to CO, CD, and MA means what? If MO parallel to MO means what? MN or not? Because MO is a part of MN. So since MO parallel to CD, so it is clear that MN also parallel to CD. That implies MN parallel to CD. Understand? MN parallel to CD. Yes or no? Yes. And again it is given that since MN parallel to CD, then after that what? AM upon DM. Okay. Again you see MN is parallel to AB. MN parallel to AB since construction as per the construction. Since construction already we have done. Okay. So since MN parallel to CD and MN parallel to AB, so hence AB parallel to CD. Since AB parallel to CD, so one pair of opposite sides are parallel. So hence AB parallel to CD. So we can say this is the sufficient condition that if one pair of opposite side of a quadrilateral is parallel, then ABCD is a what? Trapezium. ABCD is a trapezium. Okay, and this is how you can use the concept of the basic proportional theorem and converse basic proportional theorem to prove the geometrical statement. A quadrilateral can be trapezium under certain condition. Okay, using the concept of BPT and converse BPT, and this is another example of converse BPT basic proportional theorem and converse basic proportional theorem. So, and you can study there are many geometrical statements. Okay, and they are vital. Okay, and they are the statement which can be proved using the very important concept of the basic proportional theorem and converse BPT theorem. Okay, understand? So this you learn. You will learn something else about it. Okay, how can you use the concept of the theorem of BPT and converse BPT in proving the geometrical statement. Okay, thank you. I hope you will practice it. Okay, see you. I hope. Thank you for your interest. Okay, next. Thank you.